All right, so I will give a few remarks, early remarks for our ICR welcome backs to our final and last session for today. And for the last session, we have 6 presenters, which will be start with Miss Esther. Miss Esther is here. All right, so the first presenter will be Miss Esther Owusu with the paper titled The Potential of Shale Gas Resources in Peninsular Malaysia. But before we start, I hope that everyone can mute their mic for a moment for the presenter. And each presenter will be given 10 minutes for the presentation, and after that, we're going to have a Q&A session. Together with me for today, we have Miss Sharon Abigail as my co-host, and also Mr. Chiming. So let's welcome the first presenter, Miss Esther also for the presentations.
Okay.
Sharing, tak apa. Should be.
Hantar dia tu green room.
Saya punya green room tak ada.
Tak tekan.
Good day. My name is Icer Ps2 R2 from University Technology Petronas, Malaysia. I'll be presenting on the potential of shale gas resources in Peninsular Malaysia on behalf of the authors. The presentation will be going through an introduction, which would include a research objective, literature review, then the methodology, results and discussion, conclusion, then finally some references. Black shale is a dark-colored mud rock which contains silt to clay-sized mineral grains and organic matter that have accumulated together during the period of deposition. Black shales have attracted interest to researchers all over the world. This is because they serve as source rocks to both conventional and unconventional resources for hydrocarbon potential, and they also host metal concentrations such as lead and zinc, amongst others. And Hutchison 1996 described the peninsula as one of a major tin and other metal provider, which has contributed greatly to the economy of Malaysia. Although black shales are scattered all over Peninsular Malaysia, very few has been studied for their hydrocarbon potential, and therefore in this work, published and unpublished data on the scattered black shales of Peninsular Malaysia will be examined to assess the exploration potential of shales from the various stratigraphic windows. That is, we'll be using a comparative evaluation of all the thermal history plots that these black shales from Peninsular Malaysia have, and therefore we'll be using that to identify regions of thermally matured source rocks. This paper compares the reviews of some few formations which are from Peninsular Malaysia and suggests a potential cause of the variations in the black shales. Substantial information on the source rock and thermal maturity from 3 formations in the central and western Peninsular Malaysia have been included in this study. From the literature review, Full 1983 worked on the differences in stratigraphy, structure, magmatism, and the geological evolution of Peninsular Malaysia. And from his work, he revealed that there are 3 belts, which are Western, Central, and then the Eastern belts. And from these belts, we realize that the lower Paleozoic rocks are mostly confined to the northwestern zone of the Western belt and they yawn downwards. McKean et al. Also worked on 14 selected Oligocene shale outcrops from the Eastern Channel Pahang area of the Penyu Formation in the Central Belt and provided organic geochemical results from these samples, which will be studied in this work. Bayomi et al. 2018 also worked in Paleogene-Neogene shale samples from the Batu Arang Formation. Now, organic geochemical analysis of these study samples would also be included in the study for our comparison. Owusu et al. Worked on about 22 Carboniferous glacial samples from Belata Formation in Western Peninsular Malaysia. And these results from these samples are also included in our study. The method includes a review of the characterization of the 3 potential source rocks in Peninsular Malaysia. Then there will be a review on the methods such as the TOC, Rockefeller pyrolysis, and Virginite reflectance analysis, which are the main analysis carried out on the black shales within Peninsular Malaysia. These methods are studied in this paper and will be compared to values proposed by Peters and Casa 1994 as their standard. So 22 samples from the Belata Formation, 2 samples from the Batuarang Formation, and 15 samples from onshore Penyu Formation are analyzed in the study. Then the results are combined with statistical evaluation of the source rock characteristics from the 3 organic shale outcrop formations, which are exposed in western and central belts of Peninsular Malaysia. Now, binary plots of various source rock parameters will be plotted to discuss
Can
the
you hear me,
degree
Sharon?
of maturity these shales have undergone. So from the results we realized that for a plot of TOC against each of the formations, Batuarang Formation recorded one of the highest, followed by the onshore Penyu Formation, and then finally the latter formation. However, all these shales have preserved their organic matter composition, as we see a very excellent one values for onshore Penyu Formation and Batuarang Formation, and then low, although good values for the Belata Formation, although they are lower than the others. However, they are also good hydrocarbon source rocks. In figure 2, we see that the plot of TOC against the S2 shows an excellent source rock for onshore and Batuarang Formation, whilst the latter formations are very good. A plot of S2 against TOC shows that Batuarang Formation and the onshore Penyu Formation are of type 2, type 3 hydrocarbon sources and kerogen types, and then the Belata Formation are of type 4, which is dry gas prone hydrocarbons. Figure 4 shows a plot of S2 or the hydrogen index against Tmax. And this shows that the Batuarang Formation and onshore Penyu Formation fall in a region of immatured source rocks, whilst the Belata Formation cuts across immaturity to over maturity. In figure 5, the Virginite reflectance analysis is shown, and we see that for Belata Formation, it's quite high, up to about 4.5%, whilst onshore Penyu Formation is lower, up to about 0.5 or less percent in them. So figure 6 shows the maturity zones for each of these formations, and it shows that these onshore Penyu Formation are of immature source rocks, whilst the Belata Formation fall in a region of over maturity. In figure 7, a plot showing the immature shales from onshore Penyu Formation and Batuarang Formation, and then the overmature shales of Belata Formation is displayed. We see the 2 Penyu Formation and Batuarang Formation in an immature zone, whilst those from Belata Formation cut across the whole window. So to conclude, after studying these 3 main formations scattered in Peninsular Malaysia, we realize that they all have high and good source of organic carbon content, especially their TOC, which records quite excellent source rocks. However, these black shales from the 3 formations still will not qualify as productive hydrocarbon sources at all. This is because the Belata black shales, which are older shales, have been over-matured, and hence they serve as unproductive due to the various tectonism that may have affected the peninsula in its geological history. Although the younger Batuarang Formation and onshore Penyu formations have not been affected, these ones are younger than the Belata Formation, which is of Carboniferous age. However, and they therefore have not been affected by late Paleozoic tectonism, and they have very excellent pyrolyzable hydrocarbons. However, they still are immature to be tapped. as a productive hydrocarbon source rock. So in conclusion, we say that the source rock potential of most of the black shales scattered in peninsular Malaysia fall within regions of overmaturity and immaturity, with samples from these three main formations as shown in the study. Here are some references to the work that was done. The authors would want to appreciate NewTP for the support they have provided throughout the study financially under the PRF Shale Gas Grant. We are open for question and answers. Thank you very much for your time and for listening to our work. Thank you. My name is...
Okay, thank you, Esther, for a wonderful presentation. And I believe you have done a tremendous job on characterizing the black shale around, especially in your area, which is the Balata formations, and you have done a bit of comparison with the Batu Arang sample and so on. Right. So now I open the floor for any Q&A, and for the participants, you can ask the question through our live Q&A there. Okay. Can I ask you a question, Esther, about your projects?
Yes, sir, you can. Please go
Okay,
ahead.
right. So you have done, I can say, a very thorough and detailed jobs on the characterizing the shale samples from your sites. How much from your research, from your data, you can tell us that the effect of the regional the regional compression on that particular area has affect the quality of your shale?
Okay, thank you very much for the question, sir. From my results, especially for the Belata formation, I realized that the Belata formation is quite far from the main range in Peninsular Malaysia, which was an igneous intrusion, which could cause a contact metamorphism. The black shale still retain, or the shales, or the formation in Belata formation, they still retain very, very significant sedimentary structures, which could say that they are not so over metamorphosed. So probably at an early stage of metamorphism. So the original metamorphism has impacted the shales, but the stage of metamorphism is not so high.
Okay.
That's
Right.
our answer. Thank you very much.
Okay. Thank you, Esther. I have one more questions, if permissible, from Mohammed Mahamudi. Let me read the question for you. Several overmatured shale are producing gas recently, having similar properties you have mentioned in West Peninsula of Malaysia. So the question is, what is your opinion regarding it?
Okay. Looking at all these three formations, the onshore Penyu, the Pahang formation, what is the Penyu formation, the
Penyu formations, yeah.
Abatuarang formation, then the Balata formation. I am thinking from the result that the shales might cut across from immatured to overmatured, depending on the age. So the main thing that is causing most of the black shales in Western Peninsula Malaysia is as a result of the age and tectonisms that have affected the peninsula. So if any shale is deposited after the tectonism at an earlier age, it is possible for us to find oil and or gas. But anything older than probably the Carboniferous would always have the imprint of the tectonism and therefore will not be a viable source rock or reservoir rock. Thank you very much.
Okay, thank you, Esther, for the wonderful answers. All right, so thank you again, Esther, for the presentations. I think we will move to the next presenter, which is Dr. Srichan Prajapati. He will present a paper on titles "A Simple Mathematical Approach for Shale Reservoir Permeability Predictions." So now the screen is yours for Dr. Srichan for the presentation.
Okay, good day everyone. Today I'm going to present the application of machine learning for shell reservoir prediction for permeability predictions. So the idea is to apply the machine learning to predict the permeability. As we know that the shell permeability characterizations is very challenging because of very low permeability value. So the outline of this presentation contains the introduction. Then I will explain about the issues and challenges with the shell characterizations. Then how the machine learning can help to predict the porosity and permeability. And we'll show some discussion on the uh, results. And the last will be conclusions. So as we know that in present scenario, the uncondensed reservoir is uncondensed study is a prime focus around the world. It is expected that the around 2040, the 60 to 70 to 75% of the dependence on the shell. So the shell is also very economically very easy to use for this one, but there are some challenges parameters which are the TOC, porosity, permeability. These are very challenging. The tasks when we are working for the shell. So the shell is present in the reservoir both in the free and absorbed format, but there are different methods, steady and steady method to extract the shell reservoir, shell especially. Therefore, the evaluation of the potential is necessary that whether this is the economical or not. So the one of the major issues that when I'm talking about the shell related to the seismic, then we use the seismic uh, for conventional reservoir very frequently, but for unconventional reservoir we need to understand what are the challenges behind that. So the figure A shows uh, I'm showing you here the two data set, the p-stack data set A and B, and then if you see the cross plot, it looks like the very clearly distinguish the sand and shell by intercept between the intercept and gradient. But not only the intercept and gradient, but one of the major challenge is the to know that the whether this well suited to the class or not. So we need to define the AVO cross plot here. So we define different class of the AVO. So AVO 4 is AVO 3 and 4 is well suitable for the shell reservoir characterizations. Now, when we talk about the machine learning, so how the machine learning work actually. So this is the figure I have taken from the publications where you have many inputs and you have a desired output what you want actually. And very simply, you define the permeability equations, and then you just optimize the data. So once you optimize the data, so this is the results. I'm showing you some of them. So before the results, before going to the results, this is the well log data. This is the density. The red one is the density, and the neutron porosity is the blue one. And then corresponding to the resistivity of the deep resistivity and stellar resistivity, the gamma ray. Gamma ray is very indicative of the shell is very easy, and the purple color one is the velocity. So before going to see the how much is the content of the permeability or the porosity or level, we need to see that what is the content of the clay. So very simply, we can see the cross plot to see the content of the clay here, and then to more QC on the data. So this is the date the inter cross plot between the data set to see that how much is the correlation between the individual parameters, individual logs. For example, if I compare the resistivity with the density, this is 84% or 83%. If I compare with the others parameter, we can see that which logs have intercorrelation is very high. The on the right is the same, but in the different format to see that how the different logs correlate to each other. Now once you confident that our data set is quite very precise, then we can go with the result and discussion. So once we do the result and discussion, we can estimate the elastic parameters, the bulk modulus, shear modulus, Young modulus, and the porosity also. It's very easy to estimate, and we can optimize through the machine learning. When we optimize through the machine learning, we can optimize whether the porosity or the permeability. So on figure A is just only a cross plot between the impedance and the shear Poisson's ratio just to separate cell and sand. Because the Poisson's ratio is very dominant parameter to separate the cell and sand. And on the B side is the porosity modeling, just to see how the machine learning can help. See, it's very nicely explained that the original one is the original and model data set, how the machine learning can help to optimize the logs, different logs, like the porosity, shear wave, velocity, density, impedance. We can optimize this one using the machine learning. So this is that log. This log is available on the shell log here. So I've just estimated different logs here. So this is the red one is the gamma ray. Gamma ray is the high gamma ray is this is the low gamma ray is the reservoir, the conventional reservoir hydrocarbon. This is the high gamma ray is the shell here. See, it's very clearly the shell zone here, and this is the hydrocarbon here. It's very easy. And this is the permeability I have estimated using the machine learning to optimize more precise data set. Now, in the conclusion, I can say that the prediction of ultraviolet permeability is always a challenge for the shell reservoir. Why I'm saying, because the value is very low, and even though there are several methods available to estimate the permeability, but one of the major challenge is to optimize the permeability. So the machine learning can play a very enhanced role to optimize this. Then derivative-based permeability show good agreement. Generally, we do the experiment in the laboratory, which is showing very good. But when we do work on the field data set, it's quite very challenging and as well as time consuming. But once you bring the machine learning techniques here, at least you have a flexibility to see that how the machine learning can behave as a rapid and robust, and more importantly, the cost-effective method to optimize your porosity or permeability or any other logs to make a confidence between the data set that the optimized logs is more fitted with the seismic and the when we talk about the AVO cross plot. The conventional neural network is another method. Is a good pattern for the recognition algorithm. Is more useful for such characterizations. By the way, for this study, I use the CNN method to see that how very precisely we can estimate this logs. So at the last, I'm just acknowledging this research work has been supported by the CPRF, has been granted to the Associate Professor Apeshwaram, Head of Shell Research Group, University of Technology, Petnos. And the data which has been used for this study is the shell reservoir dataset, is the bayonet shell logs. We can access freely from this links. Thank you very much.
All right. Okay, thank you, Dr. Sirchan. It's wonderful presentations, because this is how to say a true meanings of combining two different, I can say, niche of knowledge between geophysics and petrophysics and also geochemistry in order to understanding more on the shale gas part. Okay, I think I have one question for you.
Yes.
It will be more general questions. I would say the formula that you create for this particular project, can it be applicable to any type of other shale formation?
Yes, sir. Thank you, Sophie, for these questions. When I was working on this one to submit this paper, so I already work on the 1 or 2 data set. But recently, I have tested on you can say more than 10 to 15 wells with different different fields, including in Malaysian field also, which works very fine, which work very fine. And by the way, I have tested with the core data also, which I didn't show in the presentation. But during that time, we don't have the core data because the data is from the outsource. But the data which I have applied on the Malay Basin and the other field, I have tested with the core sample also. So it sounds that the method works very properly. And the optimizations through the machine learning given an opportunity to see whether your data, how much is the strength in your data. So you can go around more, and if you have the principal component analysis and the singular value decomposition to constrain your dimension, it's much more useful, which I have done already, but not for this work, but for the other works. Yes, sir. Go ahead.
All right. Thank you, Dr. Swishan, for the explanation. Maybe we can patent your formula later, but I'm not sure. Okay, any questions from the floor, from the participants? Okay, you can always put your question in our live Q&A session there. I will go through your question. Okay, if no other questions, thank you again, Dr. Swichan, for the wonderful presentations. We will move to the next presenter, which is Miss Wala El Nasir. All right. So Miss Wala will present topics on organic geochemical characterizations of Cretaceous to Eocene shale and mudstone in Belaga formations. So, Miss Wala, the screen is yours.
Assalamu alaikum wa rahmatullah. I would like to welcome all of you. My name is Wala Al Nasir, PhD candidate at University Technology Petronas, Malaysia. I will present under the title Organic Geochemical Characterization of Cretaceous, Eocene Shale and Mudstone in Belaga Formation. The outline presentation is beginning with introduction, followed by problem statement, objectives, material and methods, result and discussion, and finally, conclusion. The shell is fine grain, the grain size less than 4 microns in diameters, and the mudstone is referred to the shell with a wide different composition. The current exploration idea concentrated in the unconventional and change from conventional to unconventional hydrocarbon resources. And in the recent year, shale have attracted and increased attention as a source of natural gas. Shale gas is a natural gas that was produced from low porosity and low permeability and rich in organic matter. Study area in Cebu zone, which is Belaga formation here, and here is a location map of the study area. The previous study emphasized more evaluation on the geochemical characteristic of Belugi-Eugene faults without taking into consideration the shale and mudstone on the study area. The objective is to evaluate the hydrocarbon potentiality of shale and mudstone and also to assess the type of organic matter and the thermal maturity of the shale and mudstone. For the materials and method to characterize the rock, rock eval pyrolysis was done for hydrogen index, oxygen index, Tmax, and kerogen type, and also vitrinite reflectance for the maturity level to see the geochemical variation. This is an example of lithological log I created in Belaga formation, which show the thickness of the shale, sand, mud, and coal, and also the location of the samples. The result and discussions for the fraction of hydrocarbon by pyrolysis. Here is the Rockeval pyrolysis parameters done by Rockeval, and based on this reference, we found the Belaga formation has poor hydrocarbon and has poor peaks of S2, which between 0 to 2.5. And this is implying the Belaga formation has low peaks of S2 indicate poor hydrocarbon generative potential. The plot of the TOC with the hydrogen index indicate the Belaga formation is poor to fair and fair to good as source rock, and this result was compatible with the result that was obtained from total organic carbon. Type of organic matter to see the quality. It's the most aware method done by Rocky-Val pyrolysis, which is Van Crevelen diagram, or hydrogen index versus oxygen index. And generally, the formation indicate the type 3 to type 4 kerogen, which is gas prone to inert. And also the formation has average content of organic matter and low S2. And this indicates that all the hydrocarbon generated during the oil generation window were consumed during high thermal evolution stage. And the gas could be produced or generated during the secondary cracking process. Also, type of organic matter confirmed by another method, which is S2 to S3 ratio, and also the hydrogen index. Based on this reference, we found the values of the S2 to S3 ratio between 0 to 3 and the hydrogen index between 0 to 150 or 4 to 96, which indicate that the generation of the hydrocarbon is gas hydrocarbon generation. The thermal maturity of organic matter was done by Tmax, hydrogen index, production index, and vitrinite reflectors. The plot of the production index with maturity Tmax indicates that the black formation is immature and late mature to post mature. And also the result was confirmed by the another plotting, which is hydrogen index with the T max, and also confirmed by vitrinite reflectors, which indicate the values between 0.34 up to 4.3 RO and between 1.39 to 1.07, which is late mature to post mature. To conclude this presentation, Shell and Mudstone exhibit low peaks of S2, explain that the formation is poor generative hydrocarbon potential, and the Blaga formation contain abundant of type 2, type 3 to type 4 kerogen, which are likely generate mainly gas. The shale and mudstone samples are thermally immature to late mature and late mature to post-mature, indicated by different methods, which is Tmax, production index, hydrogen index, and vitrinite reflectance data. And thank you very much for your attention, and we can go to the Q&A session.
All right, thank you, Miss Wala, for the wonderful presentation. So there's a lot of shale today.
Yes, thank you.
Okay, all right. So your focus area or your study area would technically focusing on the Balaga shale formations, and you have summarized that is in a way we can say it's a overmature type of shale formations, but in your own opinions, what do you think if you want to compare Balaga with other shale formation in Peninsular Malaysia? Because we know that we are technically, I can say in general, we are on the Peninsular Malaysia, they are quite old, and whatever we found on Sabah and Sarawak or East Malaysia, we can say it's a bit younger from the Peninsular Malaysia. What's your opinion about that?
My opinion for that, because different tectonism, different eggs, sometimes we cannot compare something in a different age or in a different tectonic history. Okay, but if I want to compare Bilaga formation with the other formation inside Central Sarawak, Malaysia, I can put Bilaga formation at the end of the formation in the zone between Sipu zone and Miri zone. Okay, for example, Nialau formation, Tatau, liam formation, Bagri formation. I put Blaga formation based on geochemical characteristic at the end of, because it's like a poor hydrocarbon generating potential. It's affected by what's called metamorphosed, because there is a phyllite inclusion inside. I put it there. But if I want to compare, it's a big history for that, because it's a different history in the Peninsular Malaysia, and different age also. It can affect the generation of hydrocarbon.
All right. I'm technically agree with your answers. Yeah, we are technically looking at two different in terms of geological age of shale, even though both are technically shale, but they are coming from two different geological age. All right. There might be one question from the floor. Okay, may I read it for you? It's more like a general questions. What do you think about the future research on the formation or the similar formation? Instead, what are the things that we can do more on this? We can see the Belaga formations.
For the Blaga formation, we need more classification on the part of mineralogical part. Like if we did by FSEM, you can do more. Okay, and also we need to do some petrophysical characteristic. I did that in my research, but we need some petrophysical characteristic, and took the core, because I took, we have to block in and do some experiments using core data, for the and petrophysical characteristic in general.
Right. So that will be how to
And
say, yeah. Yes, please.
yes, and also more in petrophysical parts. I did some research on nitrogen absorption isotherms. You can do that for also do not using nitrogen, but you can using carbon dioxide. Okay, and this will be very useful for capturing the small pore size in Bilaga formation, to see, however, if it's affected by metamorphosed tectonically, and how the porosity will be. Because if you use the nitrogen absorptions, you can capture the big porous. But if you use the CO2 dioxide, you can capturing the small porous, which can be affected for the fracturing, artificial fracturing.
All right. Okay. That's how to say, to me, this is something new. Okay, because I'm not so into petrophysics or geochemistry, but this is something new that for maybe for the next batch of researcher, they can focus on this part, this particular part. So in a way, we can technically comprehend each other's result. In a way, we can have a better understanding of the Belaga formation and also the other formations that come in the same time with the Belaga formation within the same area. All right. Thank you again, Wala, for the wonderful presentations. And
Thank you.
we will move to the next presenter, which is Dr. Firas Ayat. And Dr. Firas, at the moment, we have two papers that are going to present. The first paper will be Marcellus shale characterizations and CO2 adsorptions, equilibrium and kinetic modeling study. And for the second paper, it will be hydrocarbons and residual oil recovery with ultrasonic assisted wave and co-solvent. Right. So without further ado, for Dr. Firas, the floor is yours for your video. So for Dr. Firas, I will play the video side by side. Okay. And the floor is yours, Dr. Firas.
Assalamu alaikum and good afternoon, everyone. I'm Dr. Firas Abdul Karim, a postdoctoral researcher in the Institute of Hydrocarbon Recovery, Shale Gas Research Group, University of Technology, Petronas. Today, I want to present the research topic, critical geochemical characteristics of martial shale rocks and their CO2 capacities, a study on equilibrium and artificial intelligence modeling. Today, the work will be titled Introduction, a brief on hydraulic fracturing techniques and conventional reservoirs. Materials and methods applied in this work, analytical techniques utilized, modeling analysis, and results in discussion, final definitely conclusion and way forward. Natural gas can be produced from low porosity earthlings, known as unconventional reservoirs. Unconventional reservoirs usually consist of two main uh, types of rocks or materials called kerosene and bitumen. Unlike conventional reservoirs, unconventional gas are tapped in underground rocks, and those rocks known with their very low porosity and permeability, which require fracturing technique prior the production starts. Hydraulic fracturing, from the name of itself, usually utilizes a massive amount of water, and that's why that type of water or amount of water need to be substituted with some other material according to the um, high water consumption of this process, and definitely some of the environmental drawbacks accompanied with this process. Therefore, CO2 injection considered as the most a feasible alternative to water to be utilized in this fractioning process, according to the somehow economical process condition that required CO2 to be behaved in between phases like gas and liquid. As we can see here in the figure, vertical injection of hydraulic fracturing always followed, and CO2 or water in the hydraulic fracturing initially injected in the subsurface rock layers, followed by the injection of hydraulic fracking fluids. The fracking fluids usually consist of several surfactants, solvents, propellants to keep the initiated fractures open and operational. In this work, actually, the absorption and desorption of CO2 in that deep subsurface rock layers have been investigated. Therefore, gravimetric absorption techniques have been utilized. Four types of Marshallese shell rocks initially obtained from reservoirs from USA, and the four samples are tagged according to the place where they are picked up, and physical-chemical characteristics of those shell rocks have been studied and investigated using total organic content, Fourier transform infrared analysis, X-ray diffraction to analyze the mineralogy of the shells, Bernard Elmer Teller technique or analysis to study the physical characteristics of the shell in terms of surface area, pore volume, pore diameter, and pore distribution. Temperature program desorption have been also investigated on the shells to investigate whether there is any chemisorption in addition to the physisorption happens or occurs according to the specific minerals and clay mineralogy of the shell study. So magnetic suspension balance, as we mentioned here, utilized in this technique to study the absorption, accompanied with four isothermal models to emphasize and analyze the absorption process characteristics by itself, whether it's physical, chemical, homogeneous, heterogeneous, monolayer, multilayer, and etc. So mentioning the gravimetric absorption techniques, we need to go through some calibrations or pre-absorption measurements prior going to the absorption measurements by itself. And therefore, we need to go through two types of pre-measurement analysis, which is called blank and buoyancy measurements. Blank measurement used usually to measure the weight and the volume of the empty samples, where the analysis have been conducted without the sample loaded to the system or preloading of the sample. And for precise high-pressure gravimetric measurements, usually buoyancy measurement need to be conducted as well to analyze the exact mass and volume of the sample itself. So the equilibrium isotherm models applied here are split into two types of two-parameter models and three-parameter models. In terms of the two-parameter models, we utilize the Meyer-Friedrich and Temkin models. For the tooth model, which represented the three-parameter models, usually utilized to analyze the absorption measurements, whether it's homogeneous or heterogeneous, while Lumware, actually, in terms of two-parameter models, usually applied on the absorption data to analyze whether the absorption is monolayer compared to the Friedrich, which always supporting the multilayer and physical absorption, while Temkin is usually related to the absorption with the impact of temperature on the gas molecules interaction with the surface of the solid absorbent or the porous material. So in terms of the results and discussion, the first analysis or characteristical analysis have been conducted was the total organic content identification of the 4 samples. And as we can see here that the 4 shell samples have been shown very adequate to high total organic content. Actually, from 2 to 4% weight percent of the total organic content of the kerogen was considered as good amount of hydrocarbons to be extracted. Anything beyond 12 is considered very good and high. So as we can see here, S16 samples show more or less the lowest TOC content compared to the other 3 shell samples. And later on, we can see why I'm mentioning here S16 and correlate. I highlighted this one in particular. So according to the functional groups, Fourier transform infrared analysis, and we can see here that the peaks showed on the 4 samples are more or less identical, which referring to some carbohydrates, lignin, cellulose, fats, and some lipids, which was actually in agreement with the results obtained from the X-ray diffractometer, which representing the mineralogical content of the shells. And as we can see from the mineralogical analysis, that more or less calcite in some of the samples showing high percentage compared to the other clay minerals. On the other side, some of the feldspar and quartz showing a feasible amount as well. On the CO2 absorption in particular, calcite reported to enhance CO2 absorption better than iolite and colloids. On the other hand, other clay minerals like quartz and feldspar have always kind of negative proportional on the absorption rates, capacities, and selectivities. On the physical characteristics of the shell, as we can see here, the nitrogen DET analysis showing some hysteresis on some of the analysis of the shell in terms of the absorption and desorption, which more or less referring to the delayed desorption process. And that might refer to the shape of the shell pores and cavities, which more or less referring to the kind of open-ended pores and kind of bottleneck type of shells. And as we can see here, the surface area are more or less identical on the 4 shell types, even though their total organic content was totally different. However, the pore volume of the S16 showing the highest, okay, along with the US06 among the others. On the other hand, the pore size showing the highest for S16 compared to the others, way higher compared to the US06 and USQ06 actually, even though their TOCs was much higher compared to the S16. And now here we can, or we need actually to correlate which are the most dominant factors or parameters in terms of the physical-chemical characteristics of shell or any porous material, indeed, compared to the total organic content. So on the pore distribution, we can see that more or less for all the samples, we have the micropores distribution, and more or less most of the pores are accumulated in the micropore region, with some presence and existence of some meso and macro region. But more or less the highest amount of pores are accumulated in the micropore region. In terms of the morphological characteristics of the shell, we can see some rough surface and the clay minerals obvious available on most of the surface of shells, with the existence of some micropores available here and there. But most of these micropores have been blocked with the existence of the clay minerals on the surface of the shell. In terms of the temperature program desorption, we can see that usually there is some desorption of CO2, because actually the temperature program desorption, for those who who are not familiar with this process, while the samples are usually regenerated or pre-treated with some nitrogen, purged with nitrogen for a while, and then CO2 have been injected to the sample. Then after a while, for almost 1 hour or 2 hours after the sample have been achieving some equilibrium with that CO2, the CO2 injection have been stopped, and then heating process started with the mild injection of helium, and the outlet of the desorbed or the regenerated sample have been collected and analyzed by some TCT or GC online connected to the process. So if we have any CO2 injected afterwards of the heating process, which means that there is some CO2 have been chemisorbed because it's released only by the heat and not by the purging of the nitrogen. So for more or less the 4 samples we have here, we can see that there is some CO2 desorbed, and more or less at the same time required of the process, for 50 minutes. Okay, more or less 1 hour after heating, and until we achieve somehow 500 degrees C, which means that it's more or less considered a strong point to be breaking down. But on the other hand, we can see that the absorption process have not been achieved equilibrium, even with the highest pressures designed in this temperature, this process. However, more or less, the absorption processes have been conducted at almost 30 degrees, which equivalent to more or less the supercritical temperature to achieve on CO2. But we were careful to not achieve 70 bar for that, because we don't want to go for the supercritical phase of the CO2, and we need to maintain the CO2 within the gas phase. So as we can see here, the absorption and desorption were very similar at higher pressures, and not similar to what we conducted or what we obtained from the nitrogen BET at very low pressure. Means that a pressure drop can be overlapping the shape of the pores. And on the isotherm modeling, we can see that Lamware, Friendlich, Timken, and Tooth show more or less good agreement with the experimental data. However, Lamware showing the highest agreement compared to the others. On the other hand, as we can see here, Lamware is more or less fitting exactly the experimental data, with supporting the monolayer coverage of the gas molecules on the surface of the shell sample. On the other hand, we have also Temkin showing good agreement to the experimental data here and here. Okay, on this sample, we can see that more or less the 4 isotherm models showing a very good agreement to the experimental data. which can referring to the absorption that can cover. Since Friendlich and Lam were both in good agreement with experimental data, we can conclude that the process might following monolayer and multilayer at the same time. Also, some homogeneous and heterogeneous means that the shell sample can be covered with the monolayer first and then accumulated gas molecules on the same layers. And on the same time, we have some homogeneous contribution with some accumulation or accumulating on the shells, some active functional groups. And from that, we can conclude that the absorption of CO2 on shell actually is an innovative technique in full development, and if it's fully applied in the reservoirs with the total minimization or total reduction of the utilization of water in the hydraulic fractioning to enhance the methane or hydrocarbons desorption and production from the unconventional reservoirs and of that natural gas tap in the subsurface reservoirs. The shell samples usually is not following TOC as the main and dominant factor to identify which kind of shell reservoirs or spaces can have the highest productivity of shell. Some other kind of factors can be followed, such as the mineralogy and the porosity, especially the pore size, even though more than the surface area and volume. Some other parameters, especially the physicochemical characteristics of the shell, can have also some prominent effect on the absorption and desorption. Even as we can see that we have some absorption, but according to the isothermal modeling, we have more or less a physisorption is the most dominant and fastest rate of absorption, which can be the dominant compared to the chemisorption technique. Thank you so much, and you are very welcome to the any questions. Thank you.
All right. Thank you, Dr. Firas, for the wonderful presentations. Since we are a bit behind time, I would like to call Dr. Firas for the next presentations, which for the next paper will be hydrocarbon and residual oil recovery with ultrasonic assisted wave and cold solvent. So while for that, for those who have any questions, you can always put your questions in our live Q&A chat box there. Okay, Dr. Firas, the screen is yours.
Assalamu alaikum and hi everyone. My name is Dr. Firas Abdul Karim, a postdoctoral researcher from the Institute of Hydrocarbon Recovery, Shell Gas Research Group, University of College Petronas. Today I'm going to present a work titled Hydrocarbons and Residual Oil Recovery, the Ultrasonic Assisted Waves and Cold Solvents. The work will be titled in their brief introduction to materials and methods utilized, shell sample background, and analytical techniques utilized in this work, results on discussion, and finally the conclusion, way forward, and recommendation. So, unconventional reservoirs, usually interpreted as untapped source of unconventional fossil fuels, and therefore they need a special approach to processing with enhanced production of the organic matters and fossil fuels that have been untapped. Because of the unconventional reservoirs have very low permeability and porosity, they need further processing to enhance the productivity of that untapped shells. So most of the shells are organic sedimentary rocks, and they are have several elements, especially clay and organic matter, such as dolomite and limestone. The shell in general consists of bitumen, which is the soluble organic matter, and kerogen, which is the insoluble organic matter. The combination of the extraction techniques actually might enhance the productivity of the shell wells or the unconventional reservoirs in general. However, because of the hydraulic fracturing utilizes a lot of water, indeed, there is some alternatives have been investigated and studied so far. One of that techniques is the ultrasonication of the shell reservoirs or unconventional basins. As sonochemistry is celebrated as an important application dealt with the properties of the high-impact ultrasonic waves on homogeneous chemical configuration. However, some other kind of solvents can play an important role, especially polar and non-polar organic matter, because they are playing a dominant effect or influence on the types of organic matter and heavy hydrocarbons or the residual oil that have been tapped inside that low permeable or low porosity shell types. So the shell samples have been utilized in this work was two types of Kupang Paso formation from the western side of the peninsular Malaysia, which is somehow dated on the lower permeable Congarian based era. And the shell samples definitely have been picked, washed, sieved, and cleaned, and prepared for the extraction process. The extraction process has been split into two parts: the traditional way using the Soxhel extractor and the ultrasonic accelerated or assisted type of extraction. The hot reflex or the traditional way of extraction is usually consisted of the uh, uh, a Soxhel extractor, where most of the solvent have been replaced in the bottle and keep heated until its fumes have been condensed on the sample, which is placed in the thimble. And the extracted material have been later on substituted using a rotary evaporator and sent to the GCMS to be analyzed, and heavy hydrocarbons or organic matter extracted to be analyzed. On the other side, for the ultrasonic assisted extraction technique, the sample, which is usually 50% of the amount utilized in the traditional extraction technique, have been utilized. In this case, Talaween have been utilized like 10 mils in the ultrasonic assisted, while around 20 to 40 mil have been utilized in the traditional technique, which is the hot reflex. So since the ultrasonic probe have generated a lot of heat, the solvent and the samples need to be cooled down for the process. That usually takes around 15 to 30 minutes compared to the 24 to 48 hours of the traditional technique. So several physicochemical characteristics analysis have been conducted to analyze and emphasize the type of the shell that have been studied, such as the UV-vis, RF, TOC, surface area with the nitrogen at 77 Kelvin and up to 101 psi pressure. Surface morphology using the field emission scan electron microscopy, and active functional groups analysis using the Fourier transform infrared, and definitely the gas chromatography and mass spectroscopy to analyze the types of organic matter extracted. In terms of the results, the two types of the shell from the Kupang Pasokida, and they are tagged according to the pick place and location, have been showing some feasible to good total organic content compared to the sum of the other shells have been studied with the same techniques, more or less, on using hot reflex from other types of the world. And we can see that from the UV-vis, we can also identify that the samples, especially the KPK13, showing slightly higher values of the organic matters compared to the KPK14, even though the TOCs of the KPK14 is slightly higher compared to the KPK13. On the morphology analysis, we can see that the very rough surface on both of the samples have been diagnosed with some of the organic matter and clay minerals are obviously available, with some of the availability of some cracks and micropores available here and there on the surface. On the other hand, and with the EDX analysis, as agreed with the morphological mapping, we can see that oxygen representing the highest value of the elemental distribution on the surface of the shell samples, I begin with the silica and aluminum, which more or less representing the quartz percentage here. And the carbon is the KPK13 is much higher compared to the KPK14 in this case. On the surface physical characteristics of the shell, we can see that the samples showed more or less double molecular volume of the pores on KPK14 compared to the KPK13, and much higher surface area as well, compared to much higher pore diameter on KPK13 compared to the KPK14. This might refer to the easier penetration or flow of the solvent during the extraction process, which can be analyzed later. On the same side, the pore distribution show high percentage of the pore within the micropore region compared to the meso and macro regions on both samples. For the FTIR analysis of the raw shell samples before the extraction, we can see some of double carbon stretchings and carbon hydroxyl groups bondings on both shell samples, and which can somehow related to some bondings later on with some of the solvent that have been utilized in the extraction process. And for the general kind of extraction, we can see that the extraction of the shell samples can be related to some of the functional groups available on the surface, which can easily make some bondings with the solvent utilized for the extraction process. So for the hot reflex extraction material, we can see that the extracted matter or the residual oil retrieved from the process can ranging from C5 or 2 up to C20 with different type of and range of hydrocarbons have been extracted. On the other hand, as we can see here for the hot reflex of both samples, which are representing also some anhydrides and oxygenated compounds, and with some addition of aromatic and aliphatic compounds and components have been extracted. On the other hand, with the sonication heroin, we can see that the extraction also showing more or less a wide range of hydrocarbons extracted, somehow higher compared to the hot reflex, with some more kind of hydrocarbons extracted up to C28 or C30 even. So that's somehow doubling the amount of extracted organic matter and heavy hydrocarbons compared to the hot reflex, which somehow prove that ultrasonication assisted, even with using the same solvents, can enhance the extraction of the organic matter and heavy hydrocarbons from the hot reflex or from the shell compared to the hot reflex process. And as we can see here, more or less the aromatic and anhydrides from using the ultrasonic process is somehow typical to the hot reflex process, but with wider range and more productivity of hydrocarbons extracted. So from that, we can conclude that the ultrasonic assisted process to extract the heavy hydrocarbons and organic matter considered more feasible, more economic, according to the time that we need, a few minutes compared to the 48 hours, or even 1 hour compared to the 48 hours. And the amount of solvent needed is almost half, and the wide range of hydrocarbons extracted and a higher amount of the a higher percentage and amount of the organic matter extracted is much higher than the traditional way, which is somehow need maybe further analysis and studies on some pilot plans and some practical amount of shell, and to finalize feasible outcomes and application. Thank you so much, and you are very welcome to discuss any questions or material. Thank you so much.
All right, thank you, Dr. Firas. It was for me, it was a mind-blowing explanations and new things about shale gas. People who are looking into a micro, or I can say micro scale of the shale gas itself, and I believe the results, the whatever the finding by Dr. Firas and his team on shale gas will bring benefit to the shale gas community, I can say. Even though at the moment there's a how to say a big debates on the future of the shale gas, but I still believe there's always opportunities for the shale gas to be developed much more further in the future. All right, so I open the floor now for any questions. You can always put the questions in our live Q&A session. Sorry, live and Q&A chat box. All right. So since there is no question, I just received a message from Dr. Firas. Uh, he said that he's having some difficulties with his internet connection at the moment. And for those who have any questions, any how to say interest in the project he's involved, you guys can always contact him. He's giving me his email by Firas Firas dot a Karim Kareem at utp.edu.my, which I believe there's maybe lots of how to say questions that people who are interested in this topic to ask Dr. Firas personally about it. All right, so thank you, Dr. Firas, again, even though he can no longer listen to me because of some technical glitch on his side. We will move to the next presenter, which is Mr. Samir Al-Hajri. Okay, Mr. Samir will present to us presentation on topics nanoparticles effect on absorption of low molecular weight polymer on shale at reservoir temperature. So without further delay, the screen is yours, Mr. Samir Al-Hajri.
Hello, I'm going to present the study conducted under Dr. Verhoeven's supervision entitled Nanoparticles Effect on Adsorption of Low Molecular Weight Polymer on Shale at Reservoir Temperature. So here is the outline of the presentation. We will go through the background of the study, problem statement and why we conducted this study, the objective from this study, steps followed in this work, and then we will have to elaborate on the results and discussion. So background of the study. So shale in general covers the majority of the reservoirs, specifically the unconventional hydrocarbon reservoirs. So it is, however, more expensive to develop the conventional reservoir than the conventional ones. So that's why we have developed, why they have developed technologies in developing unconventional reservoirs such as hydraulic fracturing. So one of the main components for the hydraulic fracturing is the fracturing fluid, and apart from that is the polymer. So it is established that the polymer plays a vital role in the fracturing process because mainly it controls the properties of the fracturing fluid. So these properties actually control the efficiency and the success of the fracturing process. However, the polymer may adsorb in the shale surface, which affect the efficiency and the visibility of the project. And on the other hand, nanoparticles have shown promising results in reducing the polymer adsorption in the EOR specifically. So from that, we can look at the problem statement. So we can establish that recently the nanotechnology has been a significant focus in the petroleum industry because The addition of nanoparticles may change the properties of the drilling fluid, strengthening and sand consolidation, and improves the drag reduction. But the role of nanoparticles in the reduction of a polymer adsorption in the shell surface has not been reported in the literature. So, so from that, we can look at the objectives. So our objective is to investigate the ability of the silica nanoparticles to minimize the polymer adsorption in Marcellus shale formation at reservoir temperature, as well as to study the rheology of the three partially hydrolyzed polyacrylamide polymers of low, medium, and high molecular weight with and without the nanoparticle at elevated temperature. So the materials used, we have actually three types of hydrolyzed polyacrylamide. We have the silicate as nanoparticle, and we have the Marcellus shale. And then we have the methodology. Okay, so for the methodology, we have two parts actually. We have the solution preparation and the sand preparation. We use the standard techniques to prepare the solution and prepare 80 to 125 micron of the Marcellus size of the Marcellus sand. So yeah, that was following the standard techniques and steps. So for the adsorption test, actually we mainly conducted our adsorption test by first mixing a specific amount of solution with the sand, with the Marcellus sand at 0.1 solid to liquid ratio. And then we actually mixed, we took this mixture and we inserted it into the water bath for adsorption at the elevated temperatures. And we left the solution for 4 hours, which was enough to reach the equilibrium, which will be explained later. Then the solid and liquid were separated using a centrifuge. Finally, we have used the UV vis in order to find the absorbance for each sample, and that was correlated with the concentration and adsorption equation as shown in this slide. So from that, we can look at the results and discussion. So we have initially conducted the characterization test to find the surface area using PET for the crushed core, which is essentially for adsorption, which is essential for adsorption. Sample had the high surface area of almost 10 to 25 meters square per gram. And also we have looked at the XRD to estimate the contents of the Marcellus sample, and we can see that it is mainly it mainly includes high percentage of illite, which causes high adsorption, and that's can explain the high surface area in the PET also. So also we have conducted a morphology using the ADX images to look into the morphology in the dry Marcellus sample and aged Marcellus shale, which was aged with the polymer, and also aged Marcellus sample with the silica nanoparticle. And we can see that the polymer adsorption happened in the aged sample B from the carbon increase, and less adsorption taken place in the sample C as the carbon decreased and the silica amount increased. So particle size, we also looked at the size of the nanoparticle, and it was mainly 160 nanometer. We also looked at the zeta potential, and we saw that the polymer adsorbs on the surface of the nanoparticle, which is interesting. And we actually saw a trace of this adsorption from the voltage of the zeta potential. However, we couldn't see or quantitatively see this adsorption in the UV vis, so we neglected this thing in the adsorption calculated. We also looked at the rheology of the polymer at temperature from 25 to 105 Celsius. And we observed that the addition of the silica nanoparticle generally results in the increase of the viscosity of the polymer. Without nanoparticle, however, after reaching a temperature of 65 Celsius and above, the polymer solution tends to lose much of viscosity until it fails at 105 Celsius. And that's because of the degradation of the polymer at that temperature. On the other hand, actually, the polymer was mixed with the nanoparticle. It exhibited a more stable behavior at that elevated temperature for the three polymers. And here we can see the low molecular weight polymer as an example. For the polymer adsorption, for the polymer kinematics, sorry, we have conducted the kinetics study to see the polymer adsorption, which reached equilibrium at almost 4 hours, where the polymer adsorption reached almost more than 80% of the adsorption. So polymer adsorption at different polymer and nanoparticle concentrations. From the figure, we can see that three polymers adsorption were affected by the addition of different concentrations of the nanoparticle of the polymer at polymer concentration ranging from 100 to 2000 ppm, and adding the nanoparticle, as can be seen, has generally significantly reduced the polymer adsorption on the Marshall's shale sample. Also, on the other hand, this figure shows the effect of salinity and the nanoparticle on the polymer adsorption. The overall trend is an increment of polymer adsorption with salinity and decrease in adsorption with the nanoparticle concentration increase. And actually, this is a summary of the lowest and highest adsorption condition in this work for each polymer. And finally, the conclusion is that the addition of silica nanoparticle resulted in polymer adsorption reduction on the Marshall's shale sample to almost half, 50%. And polymer adsorption and adsorption reduction were significantly affected by the increase of polymer concentration. Highest polymer adsorption was observed for the highest molecular weight, whereas the lowest was observed for the lowest molecular weight, as can be seen from the last table. And the addition of the silica nanoparticle of the polymer solution improves the polymer rheology, particularly at elevated temperatures because of the intercalation, which is the result by the polymer molecule and the adsorption of the molecules on nanoparticle surfaces. And here is our some of the references that we have used in this study. And that's it. Thank you very much for your time.
Okay, all right. Thank you, Mr. Samir. After, 5 papers that are talking about shale from the perspective of geoscientists or geologists, finally, I have 1 paper that talking in the perspective of engineering. So, any questions from the audience about this paper? This was give a different perspective on how we look on the shale gas, especially in the perspective or in the eyes of the engineers or the drilling people. Any questions from the floor? Okay, no questions from the floor, but there's some technical glitch that been happened to our sessions or to a few sessions that they're running on the same time now. So unfortunately, Mr. Samir have left the session and waiting for him to join us back, okay, for any Q&A. But for the meantime, if any of us that have any questions, regardless of what kind of questions that you're interested with the topics, you can always contact Mr. Samir through the emails that have been given, samer.hajri, Hajri, at utp.edu.my. Okay, Mr. Samir will, how to say, will be happy to answer any of your questions, any of your doubts about the topics related to their study or their research. All right. That will be the end of our session for the presenters, but we have another special session for the shale gas research group, okay, which is one of our co-organizer for Icer this year. And there will be a pitching sessions from the shale gas research group, and the floor is yours for the presenter, right?
Assalamu alaikum and hi everyone. I'm Dr. Firasad Abdul a postdoctoral researcher in Shale Gas Research Group. Upon completion of my PhD from Chemical Engineering UTP, I joined Shale Gas Research Group since 2018, working on CO2 and CH4 absorption and desorption on shale, studying the enhanced gas recovery opportunities. Very grateful for all the facilities and equipment that we have allow us to initiate and develop very novel and innovative research. Thank you.
Hi, I'm Nadia, a research scientist at Shale Gas Research Group for almost 2 years now, and I'm currently working on shale gas characterization involving modeling and predictions. It's been quite an enjoyable role working at SGRG as we have a very diversified team of researchers from engineering, applied mathematics, and also geosciences.
My research activities is on mainly gas hydrates and enhanced oil recovery. So under this MOU between our institute and this UTP Petronas, we have visited here and we are delighted with the research facilities of this UTP, particularly this R&D section.
And I'm working there on mainly the unconventional reservoir resources, that is CBM and shale gas. In addition to that, the fracturing of different reservoirs. Come here to University Technology Petronas for some collaborative research, and for that I am very much thankful to our administrative and also Professor Icer. So here we have discussed actually for different collaborative research. We have explored different areas where we can work hand on hand together and can explore more and more hydrocarbon energy from the different resources.
I was a research attachment program student in Institute of Hydrocarbon Recovery, University of Technology Petronas. And surely I feel UTP will be a global leader when it comes to research and in hydrocarbon recovery or petroleum industry because it has international grants and extensive research facilities with very enthusiastic researchers, and it has a world ranking of 50 under 50 by QS Asia World University. So I think with having all these facilities, and it will be one of the best in the coming years. Thank you, Malaysia, UTP, Institute of Hydrocarbon Recovery, for giving me this exposure, giving me this responsibility of contributing to this industry and creating an impact.
My attachment here at Institute of Hydrocarbon Recovery is for 8 months, and my projects revolve around unconventional resources, mainly shale. My research attachment here at IHR has actually opened my mind up about the career options available, especially in the research and development sector within the oil and gas industry. IHR has the reputation of being a very quality research institute in Malaysia, so the state-of-the-art facilities that are available here has enabled me to carry out various experiments and analysis. So the technologies that is used here is actually going to give me an edge when I graduate and move on into the oil and gas industry in the future. My internship period here, I was given the opportunity to work directly under Dr. Icer, and he has provided me with constant guidance and directed me in a way of how to carry out a proper research. And through that, I've managed to become a co-author of a chapter in a book and also write my own conference paper, which I'll be presenting at a conference next month.
This system can run up to 80 degrees centigrade and almost 150 bar, which is equivalent to 15 megapascal. This is the main parts we have in the system, where our 2 canisters of absorption system we have, where we can load 2 separate powder samples or even small core samples of shell. And here we have the flooding part, where we can load one almost like 12-inch of core of shell, almost 30 centimeter or slightly less. And here are the heating system that we have in the fan to distribute the heat at 80 degrees. The DSA-100 to measure the contact angle, superficial tensions, and some of the other physical properties of the shell material, and some also other porous materials that we have. In this equipment, we can go up to different temperatures, up 60 or 80 degrees, and also very high pressures, such as 300 bar, 30 megapascal, or even more, slightly, which is a very unique equipment, and we can find it as iconic in some of the physical properties of shell and porous material all over the world. In this equipment, actually, we have some types of shell material that we can study 2 types of measurements, whether studying the contact angle and wettability of the shell, like if we say that this is the type of shell that we need to utilize, which need to be polished and very flat surface. Then we can drop the fracking fluids, dry, thin kind of, or even crude oil, or any type of emulsion that we are mimicking or predicting, depending on the reservoir conditions, and the reservoir environment, which can be in the room of the sample surface, which can be any kind of gas, such as CO2, methane, nitrogen, helium, or even some liquid hydrocarbons.
All right. Thank you, Shell Gas Research Group. First of all, because I was become the co-organizer for Icer this year, and for a wonderful job focusing on the shell gas. There's a lot of how to say details equipments and expensive equipments that they have. So anyone who interested to do a collaboration in terms of research, you can always contact the center head, which is Dr. Eswaran, for any potential collaborations. And for those who want to do any internships or postdoctoral works in UTP, you can always also contact Dr. Eswaran to have more details about it, because we have a lot of state of the art, I can say lah, state of the art equipments, especially when we talking about shale gas. Okay, shale gas. All right. Right. So I have received a new information about Mr. Samir. The new emails for those who interested to contact him, you can contact Mr. Samir through ensamyo87@gmail.com. ensamyo87@gmail.com. That's a recent email for Mr. Samir. All right. Okay, everyone, that will be the end of our session for today. Thank you for your participations. Thank you for your patience, and also for the questions that has been asked. Tomorrow we will have another sessions which we start at the same time like today. And for tomorrow we have a plenary session which I would invite all of you to join us for our plenary session, because the topic is going to be how to say eye-catching, all right? Eye-catching, all right? And before we end the sessions, if there's any other questions that you want to ask to the organizer, you can always contact the organizer. And if there any direct question for the panelists, you can always contact the panelists through the email. Okay, you can download, you can get the information from the booklets, from the program books. All right, and if no other how to say sessions left, so I would like to say thank you again for the participations from all the participants, and I hope to see you guys tomorrow for the plenary and also for the parallel session that we're going to have tomorrow. Right, thank you everyone. Have a good day and stay safe everyone.